Once again, I welcome you to my YouTube channel. Thank you so much always for following my lessons. I still remain Alera Daniel. We are going to see the continuation of the previous lesson, the last lesson which we had, and we are talking about roots of quadratic equations. In that lesson we did very many examples, which I believe you got it right. We are going to start here with some important notes. When you're dealing with the quadratic equation, there are some things which you need to take care of when we are to go with it successfully. The first note is here. Note number 1 is an expansion of alpha plus beta squared. From Pascal triangle, when we expand this, we get alpha squared plus 2 alpha beta plus beta squared. So from this expression, it is very clear that if I make alpha squared plus beta squared the subject of the formula, I'll get alpha squared plus beta squared to be equals to alpha plus beta but squared minus 2 alpha beta. So this is very important. We need to know that when we're talking about alpha squared plus beta squared, the same as alpha plus beta squared minus 2 alpha beta. Why are we doing this? We are going to reach a point where we need to be expressing everything in terms of sum and product. That's why we have alpha squared plus beta squared. We have expressed in terms of sum, alpha plus beta, and then the product. Oh, that is very clear. Note number 2 is alpha minus beta but squared. When we expand this by Pascal, we get alpha squared minus 2 alpha beta plus beta squared. So that implies that this can be written as alpha squared plus beta squared, this plus that, then minus 2 alpha beta. But don't forget that we already got this in terms of sum and product. It is right up here. So we bring this and we substitute here. So the whole expression will be equal to, instead of writing alpha squared plus beta squared, we write alpha plus beta but squared minus 2 alpha beta. That is only this one. Minus 2 alpha beta. So eventually we shall have alpha plus beta but squared minus 4 alpha beta. What is that exactly? It is just alpha minus beta but squared. It is very important. We also need to know it. What about if you want alpha minus beta only? If you want alpha minus beta, you come and make it the subject of the formula here by taking square root on both sides. So if you take square root on both sides, I'll have alpha minus beta to be equal to square root of alpha plus beta but squared minus 4 alpha beta. This is also equally important. You need to know them. Let's label this equation of ours. Let's label this one to be equation A, this one to be equation B, and this one to be equation C. Good. We are not stopping there. We still have other important things to note, and that is note number 3. It is also important to note that alpha plus beta cubed is the same as, by Pascal triangle, is the same as alpha cubed plus 3 alpha squared beta plus 3 alpha beta squared plus alpha cubed. That is alpha plus beta cubed is alpha cubed plus 3 alpha squared beta plus 3 alpha beta squared plus alpha cubed. Plus, here is supposed to be beta cubed. Good. So from there, we can connect this and that together. We shall have alpha plus beta cubed to be equals to, this is alpha cubed plus beta cubed, that is this and that. Then plus, in these two, there are 3 is common. Alpha is common, beta is also common. So we put them out. So 3 alpha beta is they are common. So if I pull out 3 alpha beta from here, I remain with the alpha only. If I pull out 3 alpha beta from here, I remain with plus beta only. Eventually, when you bring this side, the other side will remain with only alpha cube plus beta cube. So eventually, beta alpha cube plus beta cube will be the same as alpha plus beta cube minus 3 alpha into alpha plus beta. That is also very important. Let's remember this to be equation number 3, equation number D. Good. Then the last important one, which we are going to see, is alpha cube minus beta cube. That is number 4. We have alpha minus beta, but the whole thing what is cube. When we have to expand this is alpha cubed minus 3 alpha squared beta plus. It is plus, minus, and so forth. So plus 3 alpha beta cubed, beta squared minus beta cubed. So from there, we can have our alpha minus beta cubed to be equal to, we combine this and that. That means we shall have alpha cubed minus beta cubed. Then here, we can put out the common factor. Still, it is minus 3 alpha beta into, we pull up minus 3 alpha beta, I remain here with positive alpha, then minus beta. I close this. Then from there, I make this the subject of the formula. I bring this one this side. When I bring this side, I remain here with alpha minus beta cube. Then this will be plus. When this one goes to this side, will be plus 3 alpha beta into alpha minus beta equals to alpha cube minus beta cube. Good. When I look at this, we have common factors. There is alpha minus beta is here, alpha minus beta is there. So we also pull it out. So when we pull it out, we shall have alpha minus beta, which is common, into, here I remain with the alpha minus beta but squared plus 3 alpha beta. I close this bracket to be equal to alpha cubed minus beta cubed. Good. Now from there, you see we have alpha minus beta. Previously, we had already seen in equation C that alpha minus beta is alpha plus beta squared minus 1 alpha beta. And also inside here, we have alpha minus beta squared, of which we had also already seen alpha minus beta squared was this. So we substitute B and C into this equation that gives us alpha cube minus beta cube. So that implies that alpha cube minus beta cube will be the same as, instead of writing alpha minus beta, we shall write square root of alpha plus beta squared, alpha plus beta squared, minus 4 alpha beta. That is only this part. Then into alpha minus beta squared, we shall have it as alpha plus beta, but square minus 4 alpha beta. Please don't forget that we are adding 3 alpha beta. So it is plus 3 alpha beta. I close this bracket. So eventually we shall have alpha cube minus beta cube to be equals to square root of alpha plus beta squared minus 4 alpha beta, I close this, into alpha plus beta squared. This will combine with the other one. So negative 4 alpha beta plus 3 alpha beta, you just get minus alpha beta. So we will have successfully expressed alpha cube minus beta cube in terms of sum and product. Sum, product. So this is also another important thing to know. So we can call this up to equation number E. So equation A, B, C, D, E are very important when we are dealing with the quadratic expression. You need to know how they are brought about. Right up here is an example using those expressions which you have seen already. The question says that if alpha squared and beta squared are the roots of the equation, with alpha and beta being positive, required is for us to find alpha beta, which is the product, and alpha plus beta. Let's go right away to the solution. So we are saying our solution. They are saying that alpha squared and beta squared are the roots of this equation. So if the equation is x squared minus 21x plus 4 equals to 0, and the roots are alpha squared and beta squared, I'll first compare this to the general expression x squared minus sum of the roots x plus the product of the roots equals what? 0. You realize that the sum is equals to 21 and the product is equals to what? 4. These are the sum of the roots and the product of the what? Of the roots. But the roots are alpha squared and beta squared. What does that imply? It implies that if this are the roots, then the sum of these roots is supposed to be 21. And the product of the roots is supposed to be what? It's supposed to be 4. So if that's the case, I'll say sum of the roots, which is going to be alpha squared plus beta squared. Please don't forget the roots are already this. So the sum of the roots will be alpha squared plus beta squared, which is 21. Then the product of the roots, which is alpha squared times beta squared, is supposed to be equals to 4. They are interested in the value of alpha, beta, and alpha, beta. So from here, I can label this one to be equation number 1, and this one to be equation number 2. Equation 2 is very clear that you can get alpha, beta. So I start with equation number 2. So I'll say from equation number 2, alpha beta squared, because if you have alpha squared times beta squared, then it is equivalent like putting in alpha and beta, you square both of them. Should be equal to what? 4. So to get alpha beta, we take the square root on both sides. We take the square root on this side and take the square root on 4. So you get what? You get 2. So we have successfully got alpha beta. What about alpha plus beta? We get that from equation number 1. From 1, we have already seen that 1 says alpha squared plus beta squared equals to 21. But don't forget, in our points to note which we saw that alpha squared plus beta squared, we saw that alpha squared plus beta squared in terms of sum and product was equal to alpha plus beta squared minus 2 alpha beta. So if that's the case, then it implies that alpha plus beta squared minus 2 alpha beta equals to 21. Alpha beta, we already have it as 2. So that means that we shall have alpha plus beta squared minus 2 into alpha beta, which is 2, should be equals to 21. So alpha plus beta squared minus 4 should be equals to 21. We take this on this side. It's a minus, and the process becomes a plus. So that means that our alpha plus beta squared to be equals to 25. So if I want alpha plus beta only, I take the square root on both sides. So I take the square root on this, I remain alpha plus beta. I take the square root of 25. Square root of 25 is 5. Therefore, alpha beta equals to 2 and alpha plus beta equals to 5. I guess it was all that fun. Good. Let's see EG number 2. EG number 2, I need your attention here. I'll do part A. And part 2, part B, I'll leave you with part C, D, and E, of which I believe you do them very well. Just see what I'm going to do. The rest will be very simple. The question says, given that alpha and beta are roots of the equation this. Please, if alpha and beta are the roots of the equation, 5x squared minus 11x plus 3 equals 0. Find the value of the following. 1 out of alpha plus 1 out of beta. And then the question continues down. So in my solution, I'll first write this expression. 5x squared minus 11x plus 3 equals what? 0. They're saying the roots to this equation are alpha and beta. So what I do, I first express this expression in terms of the general expression where the coefficient of x squared is 1. So I divide 1 through by 5 so that I get x squared minus 11 out of 5x plus 3 out of 5 equals to 0 out of 5, which is 0. So it's already in the form of x squared minus sum of x plus the product equals to 0. The roots are alpha and beta. So that means that the sum, when you compare this to this, you see that the sum is 11 out of 5 and the product is 3 out of 5. So if the roots are alpha and beta, don't forget that this sum is the sum of the roots. So that means that sum of the roots, which is going to be alpha plus beta, is equals to 11 out of 5. And the product of the roots, that is alpha beta, is equals to 5. Having known this, I can get all this within no minute. Solution to part A. They're saying that, can I obtain the value of 1 over alpha plus 1 over beta? Yes, I can do that. How do I do it? I have to first express 1 out of alpha plus 1 out of beta in terms of sum and product. As simple as that. Where there is sum, I substitute 11 out of 5. Where there is product, I substitute 3 out of 5. So, if I start with part A, 1 out of alpha plus 1 out of beta. If they want the value, I first express this in terms of sum and product. So what I do, I first take the LCM here. LCM is alpha, beta. You see the product has already come out. So I say alpha, beta divided by alpha. I get beta. Beta times 1, that is beta. Plus alpha, beta divided by beta. That is alpha times 1, that is just alpha. So this one is like alpha plus beta out of alpha beta. It's already sum and product. So I just go ahead and substitute. Alpha plus beta is 11 out of 5. 11 out of 5 divided by alpha beta which is 3 out of 5. So divide by 3 out of 5 is then the same as 11 out of 5 times 5 out of 3, which is as 11 out of 3. That is 1 out of alpha plus 1 out of beta. Very simple. So that's the value. Then part 2, they're saying we find the value of alpha squared plus beta squared. Still, we express in terms of sum product. So part B, they're saying alpha squared plus beta squared. If you recall very well, in our notes, points to note, we had this expression in terms of sum and product. We said that this one is the same as alpha plus beta squared minus alpha beta like I said to here. If you fail to recall that, you can derive it from the first principle. How do we do that? We just say from alpha plus beta squared equals to alpha squared plus 2 alpha beta plus beta squared. You make this to the subject of the formula. That means that alpha squared plus beta squared is the same as you bring this on this side. Alpha plus beta squared minus 2 alpha beta. So that means that alpha squared plus beta squared, which you are looking for, we already expressed in terms of sum and product. Then from there, we just substitute. So alpha squared plus beta squared will be the same as sum, which is alpha plus beta. Sum alpha plus beta is 11 out of 5. So it is 11 out of 5. But square minus 2 into alpha beta, which is 3 out of 5. So this is 3 out of 5. So we simplify this. When I square this is 121 out of 25 minus this is 6 out of 5. We take the LCM. The LCM here is 25. 35 divided by 25, that is 1. 1 times 121, that is 121. Minus 25 divided by 5, that is 5. 5 times 6, that is 30. Then from there, we say 121 minus 30, that is 91 divided by 25. Therefore, we say our alpha squared plus beta squared to be equal to 91 out of 25. This is the right. I thank you so much for watching me. Let's do with the work. You'll do for part C, part D, and part E. Please don't miss the next lesson, since it will be a continuation of this. Thank you for watching. Goodbye. See you.